All right, chemistry week 17. There's only technically 2 more weeks of in person. There's only 2 more weeks because Mr. Hayes, just let me know when the lab is. I'm ready. Andrew's looking for you. And so we're going to do, you only have really 2 more weeks of live sessions. There will not be a live session the last week, whatever it is, June 2nd or whatever that is. There's not going to be a lab that day or whatever. And for some reason, if I'm ever sick or whatnot, I'll make sure I send the KMail out. Make sure you check your KMail the day before / day of to make sure that I'm here just in case I get sick on accident. All right. Okay. What? Everything I put the thing in? Oh, yeah, I put it in the wrong order. All right, so things to talk about. Again, there's only about 3 weeks left, 2 weeks left of live session. Your science notebook is due starting now, and it's going to be this window of opportunity to turn in is going to be up until May 22nd. And so if you guys, again, don't, as soon as I grade it, you're done. Like it's over and done, and you don't have to worry about it anymore. So if you get, like today, people in person, they may, who's going to turn theirs in today? Cool. Out of like the 10 kids, 2 are. Good, that's good, 20%. That's pretty good. Just remember, my time is limited, and I have so many students I have to grade. It takes about 5 minutes each one to grade. So do the math on that. Just want to make sure that you guys get it graded maybe during when you're supposed to, which would have been today. If not, maybe next week, as long as I'm here. And if not, just make sure you set up a time, or just make sure you come in when I'm not doing a live session. I'll usually go and grade, okay? If there's a line, like last semester there was a line sometimes of a few, 4 or 5 kids. They just sat down and waited, and not a big deal. I try to push through it pretty quick. I know looking at your science notebook pretty quickly if it's an A, B, C, D. I can just tell by looking directly at it. So again, make sure that's all done, ready to go. 3 weeks left. Woohoo! Yay. Eric was looking for you. You had lab equipment, I don't know. Yeah. All right, so the essential question for today is basically the concept of a polymer, and then you're also going to kind of name one compound that's considered a polymer that's organic. Organic means what? What's organic mean? Not natural or a carbon-based molecule. So a lot of carbon-based, and we'll see. I think it talks about, I can't remember if I read it or if I removed it or not. But they actually are starting to be able to use like GMOs, like bad food, but they use modified foods to actually make like a plastic type substance that is bio-based that these plants are making and harvest it. And they think down the road that these will actually be the plastics and the fibers that you use for materials such as iPads and things like that. Which now, if you do that, think about that. You don't need to make plastic anymore. You just grow fields of bioplastics or biopolymers, which is pretty cool. All right, so we're going to get into this today. So again, 55 slides, so we're going to try to go a little faster than usual. We're all carbon-based life forms. We are all in this room. Carbon can form an incredibly variety of molecules because, remember, they have so many different places you can put other molecules. They have so many other places that want to attach to it. Hydrogen wants to attach to it, oxygen wants to attach to it, nitrogen wants to attach to it. And remember we talked about hydrocarbons, how the longer or more carbons that you have, the more variety that you have. Some of these polymers go on until it's cut off. And we're going to see what that looks like. All right, so basic structures or features is the multiple bonds it can have. You can see there's a single bond between one molecule and another. Those are the 2 balls right there are basically the molecule of the atoms, and they're attached by one cylinder in between. You can see that there's the names or the suffixes is to the right there to the left, and you can see how it's single bond, double bond, triple bond, and those are various ways they can come together, and there's various strengths based upon how many bonds. Because the more bonds you have, the stronger it is. If we sat there, say, like me and Jordan wanted to hold this one hand, and we start pulling away from each other, there's a chance that we're actually going to break, like the bond's going to break. But if we would have had 2 hands and we pull away, there would be a lot stronger bond. So strong that someone even can come by and run into it, and it won't break. And part of that is the fact that you have two pieces or two bonds between molecules that allow that. You can have triples, there's a bunch of different ones that allow for this to occur. You can see that there's a difference between straight and branch. You can just see on the left-hand side of this. And the name. On the right-hand side, you can see it's branched off. It kind of looks like, I don't know, twigs or something. It kind of branches off into various different areas. And then you have isomers, which are single ones that could be added onto. You can get rings. Rings are like the hydrocarbons, those type of things. You can get one of those. So those are exciting. Okay, polymer. Carbon atoms that bond to one another in chains. Polypropylene, we can see there, from a variety of structures, including fossil fuels such as coal, synthetic polymers such as plastic, and that's the one that we're going to really kind of focus on. And then also large molecules of light such as proteins or lipids. Proteins, which muscles are made of, most people's muscles. And then there's lipids, which is basically saying like the fat, your winter coats. All right, and those are very large molecules. It says right there fossil fuels, so coal. On the right-hand side, on the bottom right, you can see this is actually a molecule structure of coal. So what it looks like. At the molecular level, being held together by atoms through various bonds, being single and double bonds. I don't see any triples in that. It looks like it's a branched molecule, or branched structure. It does not look linear to me, or line. It's branched, yeah, it kind of spreads outward. Okay, all the ways carbons created giant molecules create polymers. This is what we're going to kind of focus on. Polymers are chains of monomers joined together, and we're going to get those definitions later. But every single person in this room has a polymer near them, either on them, using it, or near them. Your pencil, pen, plastic, right? Probably looks like it. You taste it. You taste the plastic. Yeah. Yeah. Good. Taste the plastic. Good. So that particular plastic is a polymer. It is a mixture of what we're talking about in a special form to create that particular one. There's also plastic in this room that is very flimsy. It's on the front of someone's science notebook. Or we'll call this whatever we call this. Science, the binder. So there's a clear plastic sheet that protects the cover. This is also a polymer. They're different. That one part is a rock because it's meant to be that way for structural purposes. And this one here is extremely flimsy to allow for vapors within it. That's thicker, this is thinner. There's so many different types of plastic out there, or polymers out there. There's polymers out there right now like that people put on their cars to make it super light and strong. Carbon fiber. Carbon fiber is a polymer. It's just made and woven in a certain way to allow it to be super strong and lightweight. They even believe that in the future there won't be steel cars. There'll be carbon fiber because they're strong and lightweight. And then also the material that they're making them out of can be a recycled material, such as making them out of plastic bottles or Starbucks stuff. Yeah, I don't want to talk about it.
It's less strong than steel, isn't it?
What?
Like you have a steel car and carbon
fiber.
Yeah, carbon fiber. The steel is probably take more.
I would say I don't know. That would be something the idea is that depends on what steel. Because there's different grades of steel. There's like rolled steel, then there's the various whatever material inside of it, how the thickness is. There's a bunch of other things that go into steel. Also, the carbon fiber, there's different grades, I'm assuming, of carbon fiber, different thicknesses. I believe it's very comparable to steel at a lighter weight, if I remember correctly.
Because it's so lighter than plastic.
It's lighter than plastic and strong as steel. So theoretically, it's awesome, but it's expensive. You ever bought if you buy a hood, a new hood for your car, anyone ever soup up their cars? New hood for your car if you're going really fast and furious, like going really fast, but also you're very furious while you drive. And then then Vin Diesel shows up. Yeah, it happens. The front of it is typically steel heavy, but carbon fiber is lighter and about as strong and whatnot. The ones that people get confused is carbon fiber and fiberglass is different. Fiberglass is not as strong. All right, so you can see right there, various ones put together. You can see that, you can see how it's attached. Okay. Polymers are basically like a whole train together. The monomers are the little parts that go in between. So if you put a bunch of parts together, a bunch of monomers, it becomes more than one monomer, mono, one poly or more. So that's kind of where they get those names from. All right, let's keep it going. By the way, I can always send this out to y'all if y'all need it. All right, you can see right here, macromolecules or larger molecules all put together are basically a whole bunch of smaller molecules either together or repeating. So you can see that this one here, these are all repeating molecules back and forth, creating like a spider web of a substance. Polymers, when carbon molecules are combined into long chains, again, that's just what a polymer is. How this happens when carbon to carbon double bonds and a monomer is broken, a new single bond are formed to create a polymer. So that's just a very specific one right there. Okay. Now, the essential question that I posted was kind of, what is a living kind of one? What is a biological one? Living things form biopolymers, such as carbohydrates. Carbohydrates come back in biology classes. It's like energy. Okay. Proteins, which is what your body's made of with meat that you eat, they're basically a protein. Your lipids or fats, your nucleic acids, which is what your DNA is kind of made of. All of these have the same kind of idea of polymers. They're all chains of substances put together in the exact same order over and over and over and over and over and over until the chain is broken. So if you take glucose and you add a glucose to it, so you get two glucoses together, and they basically and they cut, you get the maltose plus water as an additional byproduct. Okay? If you add glucose and fructose, you get sucrose and water. Yada, yada, yada. You take these big, major chains and put them together and allow them to rearrange and create new substances. The biggest part is you get left over is water. It's one of the reasons why we use the restroom. A lot of times you think you're combining and breaking down water as you go for release. That's why you use the restroom. You're getting rid of bad stuff within the molecules inside your cell itself. All right, so polymers. Carbohydrates, again, glucose, bread, pasta. They're really awesome stuff. But you're not supposed to eat much of because you get a big winter coat. No, that's good. I agree, but it's still there. Proteins is basically muscle, meat, your hair, and nails. So make sure you eat your hair and your nails to leave room for your muscles and other meats, okay? Just make sure you leave room for it. Because no one really talks about how a balanced diet between hair and nails and meat. We're talking about protein structures. Well, you got to eat, meat and muscle, basically. When you do that, that's what you eat cows. Or people who do eat cows, I don't. But just remember, don't forget their nose and their hair. Okay, that's disgusting. But it is made of the exact same type of structure. Now, lipid is the fat, oil, butter. Butter's awesome. Can you imagine butter and toast, or butter and bread right now? Amazing. With maybe some jelly. Oh, I'm so hungry. Just roast it up. And you know what? Let's just dip it in those Hershey's dippers. I'm talking about those looks like peanut butter, but it's like Hershey's now, and it's super. Oh, yeah, just dip it in that. Little olive oil, whatever. So there's lipids. They're fat, like in oil. Now, the fat themselves are typically, let's just talk about essential fats, which come from certain plants. I'm talking about fat from animals, right? I'm talking about literally if I took a pig that was fatty, or Mr. Hayden that's fatty right now, and you actually take this substance and you cook it, what happens to it? Like, okay, take bacon. You ever like bacon? You don't like bacon, you got automatic acid like all. Just everyone here like bacon? Love bacon, right? ridiculous deal. Like, you do.
I should just against bacon soda though.
Yes, bacon soda.
So that's just the type. I know that.
So we have bacon, right? Good. Bacon is in chocolate. Also important though. But in general, we have bacon. Now, if you take bacon, it is a solid substance when you get it out of the refrigerator, right? And then you put it onto your frying pan. What happens? Okay, you said it releases fat. Okay, what we're going to say is that literally the physical change in chemistry, literally a physical change to a melting point that changes into a grease or a fat that you're going to use. Maybe to cook your eggs with later, by the way, do that. But, or maybe with your gravy. Now we're going real here. All right, or you make it with gravy. And but in general, if you let it sit there and you let it cool down, what happens to it? Anyone here ever save their big fat?
Yeah, it's just, it turns into like a butter almost.
Exactly. You can use it a whole bunch of times. Back in the day, that's what they did. I mean, you're talking back in the olden days, back when Mr. Payton was young. You know, back when the wagon wheels were going across west, you know? But in general, you can have it's still not good for you. No. It's not good for you because of the whole cholesterol, you know, death at a young age because of heart issues. Yeah, but it's awesome. Do it every once in a while. Don't do it. Then we have oil. Oil is not the same oil you put in your car, okay? Don't be cooking with that. Don't do that. But oil you can actually take oil from plants. So we have vegetable oil, coconut oil, avocado oil, sesame seed oil, grapeseed oil, I'm trying to think of all the healthy ones. But in general, you can take any oil, okay, almond oil, all these oils that are still lipids. Okay, then we have our DNA and our RNA, which is our nucleic acid. We need to have that replenished or you don't grow anymore. All right, so all contain carbon, hydrogen, and oxygen. They have to contain all of those. If they do not, they're not organic. Awesome, good talk. Okay, so here's some polymers. Here's what a protein looks like. Okay, a whole bunch of monomers stuck together. Good for us. Monomer, 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 monomer. Where will the monomers join together? Well, right there. Because what does it make? O, thank you very much. O, H, and H. There's two H's, one O, H2O, water. They come together and guess what? Water is released. Good for us. All right, again, same thing here. This is now protein. Again, these are coming together. See how we're going a little faster now? Now, carbons in general, carbon polymers, or what they call it, organic ones, as long as there's a hydrogen and an oxygen attached. Could be still fossil fuels, but there's other ones called synthetic polymers, the bio ones that we just discussed. Same exact thing, guys. This is actually a duplicate slide. So again, the list of the major four classes is carbs, carbohydrates, lipids, proteins, nucleic acids. Make sure you know that. All right, explain how organic polymers contribute to the biological unity and diversity. There's like something like 40 to 50 different monomers, those little sets that we set together, that go together. But they go together in so many different ways. They're so diverse. You have so many different pieces of your brain. And look at your eyeballs, look different than your lips. Your lips look different than your hair. Your eyes look different than everything. I mean, there's all these different parts of your own body that are completely different, but they're still made of protein, all combined in different ways in a different polymer, bio. Got it? It's kind of interesting. I always thought. I mean, I had this kid. He's like 3 pounds now. This went and had the little 3D thing where you can see what they look like, and I used to think back and go, this thing was just one cell with half the chromosomes needed for something to be alive. Another half the chromosome got in somehow. And that's biology. And in general, they fused together and made one cell. One. And for one cell, 3 pounds now. Has eyes, eyelids, eyelashes. Okay, I'm hoping for a lot of this. I don't know if you have eye until it comes out all the time. But all these different parts of just inside and outside of this body. within built. And all these polymers putting together in the right way from nucleic acid, the DNA allowing them. I think that's awesome. I don't know about that you guys. That's crazy. Think about it. One little piece and you get tall, and this has to go. Think of the error. There's like almost so little error in this building process. I mean, think about it. So if you go error, no arm. Error, no arm. Be that serious. Reading through the DNA, error, not allowed. It's crazy. Just a living child like you, it's just amazing how like it actually occurs. Okay, so you have condensation and hydrolysis, and you can see right there, you can just read the definitions. You can either remove H2O or add H2O to have them either connect or or fall apart. Anyway. Spinal carbohydrates are classified. Again, you can actually sit there and really focus on this if you want to, but they're classified as carbohydrates. There are different breakdowns of carbohydrates. You're totally, if you want to sit there and read all of them, have fun. Sugar. Everything nice. Okay, you guys like sugar? I love sugar. But sugars themselves is an OH ion that is attached to each carbon except for one, which is just equal to O, so it can take on other things. The size is about 3 to 7 carbons. They're basically separated from each other. They're aqueous solutions. You make many simple. Yeah, we have to get into that. Actually, I think you can know that. Here's the hardest part to understand. They're called saccharides. If you take 2 monosaccharides, mono means one. Say 2, and I say 2 of them. Let's take them together. Take 2 now. They're both disaccharides. It means 2 small sugars make a net sugar. Yay! Exciting, right? Energy storage, again, this is going into more biological functions, so we'll kind of skip through a lot of this. You see there's between starch and then cellulose. Lipids. Lipids are fats. If you take fat from a plate, I use bacon elevation. You take bacon and I put it with water, what happens? Do they mix and create a whole new substance? No, it explodes in the top. They're insoluble. They don't break down. They're just there. But if you put it with flour, with salt and pepper, and chop up whatever bacon or sausage you have, and you mix it together, we have gravy. You ever see gravy made? Here's the thing. If you love gravy, don't watch the video. I can see a cow killed in front of me, cut and put onto a grill, and I will eat it within 5 minutes after. It will not bother me. I saw someone making gravy, and I couldn't eat it. It's just because I know what it was. Just in general, same thing. Same thing with tofu. Watch tofu tofu.
I've seen that. I've seen how it's made.
I'll talk about watch.
Pretty good. Depends on what it is, high quality or low quality. The best is when I eat a Slim Jim, and I read it, and it says, other attractions to beef. It says beef, and it says pork, soy, and mechanically separated chicken. Did you just say it's chicken? I don't even know some machine ripped it apart for me. I don't need to know that, but it says that. When I point out to my wife every time, I'm going to use my mechanically separated chicken. It's really good. These are insoluble due to their non-polar combinations. Fat is used for energy storage, compact fuel reserves, cushioning, insulation. That's why I have it. There's the insulation and cushioning in case I fall. I mean, if I fall, I need to make sure I don't bone me and break stuff. So that's why I chose to be fatter than I used to be now. Does that make me feel better? Does it make me feel better? Yeah, I feel better. Energy storage too. People who need the energy or need the storage, they actually can say that, and you can use it as a fuel. And so that's really kind of beneficial as well. All right, continue. We're going to kind of go faster here. Steroids. Cholesterol is a type of steroid, so we're good. Let's go here. Some of the stuff I pulled off the internet because I think it's really interesting, but it doesn't directly relate to what's in K-12 right now. I just thought it was interesting, some of it. Some of it was boring. You guys ever see on your label versus saturated, unsaturated fat, do you ever care what that actually means? Or you just eat it and go, this is tasty too. No? I see. Saturated fat. All right. Basically, the saturated, unsaturated fat. Saturated fat, there's no double bonds between the carbons until it has a minimum number of hydrogens. This is the big one. This is the easiest one. Solid at room temperature. So saturated fats are pretty much like animal fats. There's unsaturated, which is a liquid, which is plant fat. So unsaturated fats are technically better for you. Does that make any sense? So you look at it, even ever eat an Oreo, they're amazing. I used to eat a whole line of them at a time when I was, don't judge me. I feel judged. This is ridiculous. Oh, someone's saying they're probably judging me too on the internet. Let's see. Essential question. We're talking about how fat I am. All right, but if you eat one, looks like you eat a whole line of them, don't judge me. You know how many calories are in one cookie? One cookie. 75. Woo! Look at it. Google it. Someone's serious. Ask serious. Dude, right? You're serious. Someone's going to look it up on the internet, all right? I want to know the nutritional guys too and Oreo. All right. We'll keep going as we talk about that. Oh! Yeah.
Okay, so I've been seeing this in this unit. What is the difference between the dashes and the equals between them?
Double bond, single bond. Yeah, it says right here there's no double bond between the carbon now. These are all single bonds. Oh, we have it. Forget. All right, so check. All right. All right, so the people on the internet, if you want to look it up too, and just not ever eat an Oreo again in your life. And this is probably the regular Oreo. I eat the double stuff. Look up double stuff. All right. So we have our nutritional guide for, okay, so 3 cookies is a serving, by the way. 3 cookies. So if you eat 3 cookies, those little dinky things, that you eat with milk, and milk's even bad for you too. Oh, yeah. Okay, you have 160 calories. And a third of it, cut it in like 1 cookie worth. Out of 3 cookies, 1 cookie. 60 calories of fat. That's just fat. So imagine just eating 2 cookies and just eating a block of fat. It's still eating fat. Don't get me wrong, eating it and eating a fiber with it will probably help, like a broccoli, because those taste good together. And the broccoli, the fiber will help push it through faster. Yeah. Let me see here. So you get 7 grams of fat. It's like taking a scoop of the fat from that pig and eating it. Just a scoop. Saturated, which is that the good one or the bad one? 2 grams of it. So a third of it is just pig fat. The other one is vegetable oil type stuff. 0 cholesterol. Must be good for you because there's no cholesterol. I guess if you have a bad heart, you can still eat this because the cholesterol is low. There you go. That's good. Sodium's high, potassium none. And then here's the carbohydrates. And 3 cookies. 3 cookies! You get basically, I think it's like 2 tablespoons of sugar. That's disgusting. Sounds amazing, you're right. Okay, that's, I mean sugar, you have 14, that's ridiculous. Oh, don't worry, there's some protein. So just in case you're, on a diet and you eat protein, there is 2 grams of protein. So basically what we have is horrible. Double stuff. 3, does it say 3 cookies? 2. Not even 3 cookies anymore. We're talking about 2 cookies. What is the calories? Same calories for 2. I'm guessing that white stuff in the middle is what's bad for you.
That's the best part.
I agree.
I feed my dog the
You know, okay, you do know. She looked your direction.
Hey, my dad knows you.
Well, this is the problem. This is the problem, man. When I was a kid, back in the day, when I was a young pup, they don't even make these anymore, I don't think. They have like the super Oreos.
They make them.
They still make them. Look up super Oreos.
They call them mega stuff.
Mega stuff, which they're like this big, right?
No. Not that big. They downsize them to about that.
No. I'm talking like circular.
Oh, circular? No. It's like the same.
Oh, no. Okay, no. Oh, no. I don't. What is it? I'm looking. Okay. It was like really big Oreo cookies from the 1990s. I don't think so. Okay, well, check this out. Let's get through this. It was literally like the size of, like a compact disc. Yes, I said CD for y'all MP3 players. And then there was like an inch thick of frosting. Oh, yeah. Then there was another cookie on the bottom, obviously. And then I ate that. It was probably 3 million calories. It sounds, I remember eating it going, this is amazing.
You're looking at all this all wrong. Why are you looking at colors as bad thing? I'm looking at it as a video game. Every time I go to put like 2,000 points.
The more points you win. The more points, you're less you're on Earth. All right. All right, so let's try to get through this. There's a lot of just repeating stuff, so we'll get going. So proteins again, look that up for me though. You see it? Okay, look up pictures. Look in the picture images. Nothing? All right, I'll look in a second. It was a dream. I bet you they had it for like 1 year, and they're like, this is going to kill everybody. So let's not ever make this again. Just like bonkers. Were you around for bonkers? I don't think you're around for bonkers. Bonkers are amazing. They're like Starburst instead of a Starburst. They're amazing. Oh, yeah. All right, so proteins are extremely important for you. Sorry to cut you off. They're basically made up of amino acids, and you need that. So when you grow your body, when you yourself are growing, you're going to make meat. You're making more of you. How the heck do you do that? You have to literally jack the stuff from an animal or another source of protein. The animal that you just ate, you're literally becoming a part of it. You're not part of the animal, okay? Is that it? That's amazing. Oh yeah, that's it. Oh yeah. The irregular order is next to it. No! Amazing! Sorry for people on the internet, this is the experience you get from coming in person. Look up like world's largest Oreo or something, but if you see a thicker layer in the middle. Oh yeah. Oh, did you see that? Oh, you want to see it over here? Sorry. Here's it. Oh, yeah, we've had one over here. Us people that are older, we've had this delicacy. No. All right. So again, you made up. So in general, you guys need to eat meat or a substance of protein. You need it. If you do not, you will get sick and not be good. That's part of the thing you need. Even if you're a vegetarian or whatever, you still need to have a source of protein. You need to be able to take these amino acids, eat them, and your body will function on them. If you don't, because your brain, like there are people out there like, I'm not eating any type of protein. It's like, because your body needs it. I'm making a choice. Well, yeah, you are. A lot of choices in life are bad. Happens to be one of them. So you probably should move past it. Now, again, if you're a vegetarian, that's awesome. But you need to be able to supplement with something like a tofu or something that has a high protein. Oh, my son loves protein. He's a weird child. All right, so you go continued. All right, so important thing. These allow for structural support, storage of amino acids, transport. These are things it does for your body. Helps defend against for your diseases. Helps fix things. As catalysts or enzymes for different processes. These are extremely important for you guys to have. Amino acids, 4 components, hydrogen atom. They have a certain group inside of it, an amino group as well, and then there's a value R group. Again, these are way This is college level stuff. You don't need to specifically know that. Again, you don't need to know that. You need to know that. No, you don't need to know that. But I'll leave them on there so you can always pause them and you can read through them if you'd like. Nope. 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 Oh, nucleic acids. Okay, so nucleic acids contain phosphorus. That's the importance of the phosphorus cycle. People remember that from biology. They store and transmit hereditary information. So, example, if your cell, like every single second of the day, cells fall off your body. That's what dust is. I mean, it's just, right now I'm just shooting it into the air, breathe it in. I mean, in general, it's in the air, it's everywhere, okay? Everyone's around everyone. But these cells just don't go away and that's it. They're remade. If you didn't have the right, like, code, basically, to remake it, then your skin is not going to grow back properly. That's one of the things cancer comes from, guys. Down the road is basically a mess up. The inside of a DNA structure sequence, it's like, make it, stop. There's a stop sequence that says stop growing. We're done. We're good. We have enough. Move past this. Cancer, not so much. It runs past it. It just continually grows and 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 grows. Cancer cells are your body cells, just on steroids. Like, just go crazy. That's what it is. That's why it's extremely damaging, because it takes so much energy and process to that. It's damaging to everything around. It's like a weed growing in the grass. You need to get rid of it. And so the nucleic acids need to be read properly. So you are what you eat. They say, in general, if you take away genetics, which genetics is a big part of cancer, is if it goes in your family, it's genetically inclined to your particular body. You still have a chance is if you start eating properly. You are what you eat, literally. Right now, Jordan is a Frappuccino. What is it? What's it? What? A carbon ribbon, caramel ribbon, crunch, Frappuccino. That's just that. Okay, that's all it is. Yeah. Google. What is it? Longest drink you can ask for at Starbucks. Sorry, off subject. No. There's one. Not largest drink. The name.
Largest name drink.
Longest named drink at Starbucks. Okay, we'll keep it real fast. Okay, so summarize the nucleic acids. We store and transmit heredity. It's very important. If you don't have that, that's what we call no bueno. You can see there's the various bases of the nucleotide. So this is what DNA is actually made of. It's phosphorus, nitrate, pentose, which is ribose, and then deoxyribose, which is DNA. Ribose is RNA, deoxy is DNA. That's the R and the D in the word. Distinguish between these various types of substances. Again, you don't need to know this, but it's what you should learn in biology. Again, a lot of the stuff I told you guys, you don't really need to really. This is the last slide. If you have any questions, please submit them to me. We're going to go ahead and look up the longest. What's the longest name? That's how long it is. You got it? Wait, I want to hear it. I see if you have the same one. Maybe a different one. Okay.
Double ristretto, Benson half soy, non-fat decaf, organic chocolate, brownie ice, vanilla, double shot, gingerbread, frappuccino, extra hot with foam whipped cream, upside down, double blended, one sweet and low, and one neutral sweet and ice.
That is a legit. Is that the same one you got? That is a legit request at Starbucks. You're all. You just like, all you do is you just take off your little green apron, put it on the cash register, and you just walk out the door. Yeah. All right, so the people on the internet, if you guys want to go and take off, put the essential question in there. We're going to go ahead and quickly go through, because we need to grade the 2 or 3 science notebooks that are in the room. Remember, we need to get that graded. It's 100 points. If you come to me on the 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, 1st, 2nd, or 3rd of this month and next month, and you do not get it in before the 22nd, I'm going to say, I'm sorry, that's too bad. You get a 0. All right, so have a good rest of your day, guys. go back to the essential question. So I will go back. Oh, I need to go back. Give me a second. Someone remind me I need to go back to the essential question. There you go. There's the essential question.